Hess's law problems can be quite complex, and there's no by the numbers procedure for getting your answer from the information given using a series of steps. Instead, like dimensional analysis, you have to see how the pieces of information given link together to get you from point A to point B. Remember, in a Hess's law problem, you're always looking to describe how you get from reactants to products in a series of steps. And for each of those steps, you should be given a chemical reaction with a known enthalpy change value. So the idea is you start with the chemical reaction that you're given that has at least one of your reactants in it. And you say, okay, to do this first step, the enthalpy change will be this. Now I need to do a second step that either gets all my reactants involved in the chemical reaction or gets my reactants to the products that I need as part of my chemical reaction. So I slide in another chemical equation and I say the enthalpy change for this step will be this. And then every time you have to make a phase change or a chemical change between reactants and products, or a phase change from reactant in the liquid phase to the gas phase or vice versa, you use a chemical equation with a known enthalpy change to accomplish that step. As you lay in these blocks, you can cross off unneeded chemical species that don't appear in your overall equation if they appear on opposite sides of the reaction arrow. Remember that if you reverse a reaction, the sign on the enthalpy change value flips, but the magnitude stays the same. If you do a reaction twice or do a reaction 3 times, you add up all 3 of those enthalpy changes, or another way of looking at that mathematically is you multiply the enthalpy change by 2, or you multiply the enthalpy change by 3. To be able to solve Hess's law problems reflexively and well, you need to practice, 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 practice. I have one example that I'm going to walk you through here to show you the basic technique. Then I'm going to have a follow-up example for you to practice that comes from the textbook. On Wednesday, we're going to be doing a lot of guided practice where I'll have some problems for you to try, and you can check your solutions against my line of thinking. Make sure you do the practice and play around with the Hess's law problem-solving strategy. And it may take a little while to get good at it, but it's worth the time invested. In the real world, Hess's law is one of the most useful tools we cover in this chapter because this is the basis for estimating quantitatively how much energy is available from different types of fuel sources and different ways of chemically processing fuel sources, fossil fuels, alternative energy sources. How much energy are they actually going to provide? So Hess's law may seem really artificial, but it's actually tremendously useful in terms of predicting the energy available in a fuel source, among other things.